My name is Anush Nathan. Register number you are creating CS1233, and this is the 10th experiment to solve n-queens problem using backtracking. So this code is written in Python here, and here in the first line we have a definition attack I of j. This is for rows and columns for k in range of 0 to n. So here in this range we're checking if b of I of k is equal to 1 or b of k of j is equal to 1, return true. So this is if to check if there is any queens placed in the same row. Then for k in range of 0 of n, k for L in range of 0 to n, if k plus L is equal to I plus j, or k minus L is equal to I minus j. If k of b of of L is equal to 1, then return true or return false. So this is for to check in form of diagonal if there is any queen in that particular diagonal. Definition of n queens. So this is the number of queens placed. So if n is equal to 0, then return true. For I in range of 0 to n, for j in range of 0 to n. So until these conditions are true, then if not attacked I of j and b of j, I of j is not equal to 1, or b of I of j is equal to 1. So if n queen minus 1 is equal to true, return true. So b of I j is equal to 0, return false. N is equal to integer of input, or enter the number of queens. So here b is equal to brackets open of 0 into n. So for underscore in range capital N, so we have this an empty list here p. So n queen n of n for I in b, print I. So for I in range of n, for j in range of n, and while this is going on, if b of I of j is equal to 1, you add this element into the list using this append function, then print place, then the value of the list p. So yeah, this